Okay, we are in Unit 2, Lesson 13 today. And out of the textbook, this is Chapter 8, Section 6. And the topic for this lesson is solving rational equations and inequalities. We have two content standards to talk about in this lesson. The first one is create equations and inequalities in one variable and use them to solve problems. And the second one is solve simple rational and radical equations in one variable and give examples showing how extraneous solutions may arise. The math practice that we need to focus on is attending to precision. Previously to this lesson, we've simplified rational expressions, and in this lesson, we're going to solve rational equations and solve rational inequalities. We're going to look at rational equations, weighted averages, and rational inequalities as some new vocabulary for this lesson. So our first example, we have this equation. It says 5/24 plus 2 over 3 minus x equals 1/4. We need to solve this equation for x, and then we're going to check our solution. So the first thing we want to do is get a common denominator for all three of the expressions in this process. So we found the common denominator of 24 times 3 minus x. And then we want to figure out what each term is missing from 24 times 3 minus x. So this first fraction is obviously missing the 3 minus x. So we're going to multiply the top and bottom by 3 minus x. This term is missing the 24. We're going to multiply the top and bottom by 24. And this term is missing 6, because 4 times 6 gives us 24. So it's missing the 6 and the 3 minus x. So we're going to multiply the top and bottom times 6 times 3 minus x. When we do that, we're going to multiply out, we're going to distribute, we're going to simplify, we're going to end up with the expression 15 minus 5x plus 48 equals 18 minus 6x. And then from there it's just basic Algebra 1 stuff. Just move the stuff around, combine your like terms, simplify, and solve the way you've known how to do for years now. So when we do that, we get the answer of x equals negative 45. We're going to check our answer just to make sure it works out. Plugging negative 45 back in. 3 minus negative 45 becomes 48. 2 over 48 is the same as 1 over 24. 5/24 plus 1/24 is 6/24. And 6 over 24 reduces to 1/4. And so therefore the answer works out. We know our solution is correct. All right, here's a check your progress problem for example 1. Pause the video, read through the problem, solve it. When you have your answer, go on to the next screen. Okay, our answer for the check your progress is B, negative 1/2. All right, for example 2, we have another rational equation. It's a little bit more complicated because we have quadratic expressions, which we're going to need to factor before we can do anything. So let's see how we're going to attack this problem. So again, the first thing we're going to do is find the common denominator. Our common denominator this time will be p plus 1 times p minus 1. So we're going to multiply this first fraction times p minus 1. And this second fraction over here is missing the p plus 1. So we're going to multiply the top and bottom of this fraction times p plus 1. And in order for this term p to have the common denominator of p plus 1 times p minus 1, we need to multiply it also by p plus 1 times p minus 1. So when we do all that, there's going to be some stuff that cancels and simplifies. Let's look for some more stuff on the next screen. Okay, we multiplied all of these expressions out just using FOIL, and then we're going to combine like terms. So you have a p cubed, there's no other p cubes on the left side. We have negative p squared and negative p squared, that's negative 2p squared. Negative 5p and plus p is negative 4p. On the right side we have a p cubed and another p cubed, it's 2p cubed. A p squared, a negative 7p, and a negative p gives us negative 8p. And then we have a negative 7. We're going to get all of our variables on one side of the equation. So when we do that, we're left with 0 equals p cubed plus 3p squared minus 4p minus 12. And from there, we need to factor that expression. Let me go back to the screen. Looking at this expression, we have 4 terms, so we're going to solve that. We're going to factor by grouping. Remember, you need to group the first 2, see what they have in common, group the last 2, see what they have in common, and pull it out. When we do that, we would be able to take out from this first pair, this first group right here, we can take p squared out, and we'll be left with p plus 3. So we know this second group over here is also going to have a p plus 3 that's left over. And so that would be negative 4 in here, because negative 4 times p gives us negative 4p, and negative 4 times 3 gives us negative 12. So then our 2 factors would be p plus 3 and p squared minus 4. And obviously p squared minus 4 is a difference of squares, which we can break down pretty simply as p plus 2 times p minus 2. So we'll see that on the next screen. So here they've simplified that p squared minus 4. So we have 3 solutions. We're going to find the 3 solutions now by finding what makes each individual factor equal to 0. And so we'll get the values of negative 3. They're going to plug it back in and check, make sure it works, and it does work out. We're trying negative 2 now. We plug negative 2 in, simplify everything, and we find out that negative 2 also checks out. The 2 sides are still equal. And lastly, we're going to check positive 2. Plugging in positive 2 every time we saw p in the original equation. Simplify, and we see that the 2 sides again are equal, and so therefore p equals 2 is another solution that we are sure works out. So we know our solutions are negative 3, negative 2, and 2. Okay, check your progress problem. We have x over x minus 2 equals 2 over x plus 4 minus 2x over x squared plus 2x minus 8. So work through the problem, pause the video, have your answer, go on to the next screen. Okay, you should have found the answer is b negative 2 for this problem. Okay, our example 3 is a real-world problem. It's about mixtures of solutions. It says Aaron adds an 80% brine solution to 16 ounces of solution that is 10% brine. How much of the solution should be added to create a solution that is 50% brine? And if you're not sure, brine is just a mixture of salt and water. And this is a typical kind of problem you might see in a science class for chemistry or something like that. And if you're just in chemistry, like this problem would probably be super confusing to you, but hopefully you can apply principles of Algebra 2 that you're learning right now to these kind of problems whenever you're taking chemistry. So let's check out what we do first. So the first thing we need to know is that Aaron needs to know how much of a solution he needs to add to the original solution in order to create his new solution. And each solution that he's going to make has a certain percentage of that solution that's salt. And the percentage of brine in the final solution has to equal the amount of brine divided by the total solution. So originally, the amount of brine that he had was 10%, and he had 16 ounces of that solution. Let's go back and make sure. Yeah, see, he has 16 ounces, and 10% of it is brine. He's adding an 80% brine, but he's not sure how many ounces of that he's going to need. So our new expression would be just adding those two expressions together. And the amount of solution he had, originally he had 16 ounces, and we're not sure how many ounces he's adding, so our total amount of solution is 16 plus x. So to find the percentage of brine in this new solution, we need to take the amount of brine divided by the total amount of solution. So we're just going to take this expression and divide it by that expression. We're going to set this fraction equal to 50% because we want the final solution to be 50% brine. So simplifying the top, we get 1.6 plus 0.8x equals 16 plus x. From here, one thing we could do, like we have been doing, is just finding the common denominator, which would be 100 times 16 plus x. This is missing the 16 plus x, so we're going to multiply the top by that, and this is missing 100, so we're going to multiply the top by that. Another thing you could do is just cross-multiply from here and then distribute your values. But either way, no matter which method you choose, you're eventually going to end up with the expression 800 plus 50x equals 160 plus 80x. And then just following basic Algebra 1 principles here of solving equations, you're going to get all the x's on one side, you have 30x, get all your plain numbers on the other side, you have 640. Divide by 30, you're going to get 21 1/3, or 21.3. And so this tells us that Aaron needs to add 21 1/3 ounces of the 80% brine solution to his mixture in order for his new solution to have a final percentage of 50% brine in it. So just checking our answer here, we're going to plug the 21 1/3 back in. When we do that, this right side simplifies down to 18.666 repeating, which is 18 2/3, over 37.3 repeating, which is 37 1/3. If you divide those on your calculator, you should get 0.5, and obviously 50 over 100 is also 0.5. So our answer works out. Okay, check your progress problem. Same process here. It says Jana adds 65% base solution to 13 ounces of solution that is 20% base. So the original is 20%, and there's 13 ounces of it. We're adding 65%. We're not sure how much. How much of that solution should she add in order to create a solution that's 40% base? So just follow the same process as example 3. When you have your answer, go on to the next screen. So our answer for this problem is 10.4 ounces of 65% base solution is what Jana needs to add in order to create a solution that's 40% base. Okay, we're going to pause here and pick up with example 4 in the next video.